Hello everyone. In this video we will do a calculus problem where we are given a curve and this curve represents a function f, and from that curve we will attempt to sketch the graph of its derivative y equals f prime of x. So here's the graph of f. I can write y equals f of x. And we will sketch the graph of f prime. All right, now let's get started. So the graph of f is given by this blue curve, this curve that's in blue, tracing over in red. But it's given by this curve. Each point on the graph has an x-coordinate and a y-coordinate. There is another number that we can attach to this, associate with this point, which is the slope of the tangent line. And what I'm going to do is, at this point right here, is sketch a tangent line. This is a rough sketch. I think it looks like a horizontal tangent line. That might be a little off, but okay, it's going to be very rough. Not that rough, a little bit rough. So I think right here I have a horizontal tangent line. And I look at that and see horizontal tangent lines have slope equal to 0. The calculus that comes in here is that slope is equal to derivative of the function. What I mean is the slope of the tangent line equals the derivative of the function. So that's what I mean by f prime equals 0. I mean the slope of this tangent line is 0. And that is a number associated with this point on the curve. When I come down here, I plot that point. I could even make a little, little table as I'm doing here, but I don't really want to do that, but I guess I'll try it first. See what happens. When x is 0, what this is saying is that f prime is 0. And I come and plot a point there, except I accidentally erased everything. Hold on, don't do that. I come down here and plot a point. That is the point, x is 0, f prime is 0, because this is the graph of f prime. So, all right, I have that. Now I'm going to go all the way over here to another place where I see that the tangent line is horizontal, and therefore the slope is 0. I'm going to say that has f prime is 0. Now, on this graph, it doesn't have any markings for the values of x and y. I'm just going to throw those in there. And the reason I'll do that is just so I can fill out this table, but I don't need to do that. And that's not the original problem. But I did that anyway. Okay. So, according to what I see here, roughly speaking, when x is 2, f prime is 0. So I'm going to go right below it and mark the same thing. Say this is 2, and right there f prime is 0. So my method is I look for places where I see a horizontal tangent line. Here's another one. This problem's copied out of a book, and I guess in the book they also don't have numbers for x, but I'm just putting them there. I don't think it hurts at all, so that's why I'm doing it. At -2 I put 0, and it might not help. It might make the whole thing more messy and more confusing or something, just to add more numbers there, but I think it's okay. That's why I'm doing it, because I think it's okay to do that. All right, so the idea is that the y coordinates of this graph are these numbers for slope. I didn't fill in this as f prime is 0 because the tangent line is horizontal. Now I'm also going to look now to see where the tangent line seems to be increasing at a 45-degree angle. I will draw that tangent line. If I have a tangent line that increases at a 45-degree angle, the slope is 1, and that's f prime. Okay, think about a 45-degree angle. If it's at a 45-degree angle, rise over run, if I were to draw a little triangle, rise over run would be 1 divided by 1. Or 2 divided by 2. Either way, the rise to the run is the same if it's a 45-degree angle. It's true we have to think a little bit about triangles, maybe, but maybe not. I think it's believable. But if you think about a 45, 45, 90 triangle, the two legs of that right triangle are equal. So rise and run are the same. Rise divided by run is 1. So, okay. So if I were looking at just putting these numbers that I actually put in there, wasn't part of the problem to put 3 in there, but that could help because I'll put in 3 and 1. So at 3, I'm at 1 up here. But you don't have to have these x values written. The points would be, sort of still sitting the same there. I see over here, I think, oh, okay, the derivative is equal to 1 because the slope is 1 there. And that might not be exactly right, to say the least. But anyway, let's just do that. Maybe it's more, I don't know. It could be 1.5 or something, but it's about 1. Now I'm going to look to places where it appears that the tangent line is decreasing as, from left to right, the line goes downhill, or decreasing is the correct language. It's decreasing at a 45-degree angle. In that case, I have f prime is -1. Let's change the color there. F prime is equal to -1 there, around. So that looks like around like that. If I fill out a little bit here, this is -1, okay. And where else do I see that the slope looks like it's decreasing and it's a 45-degree angle is over here. Now what is that? That looks not a whole number, that x value, but I'll take it anyway. Okay, -1. Oh, by the way, I didn't over on my chart over here write down that at 1, f prime seems to be 1. Or no, -1. And that at this next value, which is at, I don't know, -2.7 or something. Let's say -2.5. It's really very roughly written. I have -1. Actually, it goes all the way up to 3, I would say the slope is -1. Maybe I'll just put that. At 3, the slope's -1 also. Sort of stays about the same throughout there. Okay. So now, okay. This is what I'm going to do. I'm going to connect these with a nice smooth curve. And there is a question about whether that really even makes sense, but it does. And I'll tell you why. Because here's the slope 1, and then also I put in red here, the slope is 0. In between the slope 1 and the slope 0, the slope is, say, 1/2. Somewhere it's 1/2, like there, it's 1/2. Then it's 1/4, then it's 1/8, 1/10. So it continuously changes from slope 1. And someone could say, no, I don't think you got it right. It doesn't look like the slope's 1. It looks like the slope's 1.5. All righty, you could say that. But I do not want to get caught up too much about the precise numbers. I'm trying to get a rough sketch of the graph. I think I did the job, all right? And that's what we're looking for. Okay, I have that one. Let's look at this one, also out of textbook, some book. I always start to see where the tangent line is horizontal. Now, then I next go, where does this tangent line meet at a 45-degree angle? This left one, it's increasing at 45. The right one decreasing at 45. So the right, that one on the left over here, I'll put slope as 1. The other slope is -1. Then I'll just, this time, instead of applying points, I'll just put what looks like 1 to me and -1. Roughly speaking, of course, how do I know it's 1, -1 without marking the curve? So I could do that as I go. Okay, now, a little bit tricky. Let's pick a different color, sort of bright here. Right there that I just drew that, the slope's steeper than 1. That means the slope is greater than 1. Maybe the slope there is, maybe it's even 4, maybe 3. Okay, but the point is that it's increasing. Okay, the farther left I am along the curve, the greater the slope becomes. So, like over here, it looks like the slope is like really, I don't know, 10. So what's happening is the curve is doing one of these things. It becomes, the slope seems to be becoming infinitely, it approaches infinity. The tangent line becomes infinitely steep as we move towards that point there. And I didn't really get that one exactly right. Let me redo that. Maybe, okay. All right. And then over here on the other side here, let's see what we have. Okay, right here, it's too thick of the line. Okay, right here, the slope is steep, but it's negative because it's decreasing. So rise is it goes down and then to the right. So rise is negative, run being positive, rise or run. All right, so what's happening here is that, okay, I think my picture could be improved upon. What I would say is going on here, like it can be improved a lot. I would say that the way we should look at it, the slope is getting so steep, is that we have a vertical asymptote exactly right where it meets at that point where it meets the x-axis. And I knew that before I started the video, but I sort of started writing and getting in the details. And so what we see is then that as we move towards, on the left, as we move towards that line there, the tangent line becomes infinitely steep. So it's going to look like this. And on the other side, it's infinitely steep, so it becomes larger and larger, but negative. So something like that, I would say. Interesting. Okay. So that, I mean, we could try to find an equation for that curve. I don't know what that would be. But this again is f prime, and this is f. I hope I made it clear that the next problem had the same directions. So this is f prime of x, and the original one is f of x. And this time, on the second time around, I did not plot any points. First time I did, but you could plot points also. All right, this is not easy, and I did an example, but maybe you have to chew on that, maybe watch different people do the videos, but that's my take on this. And there's also other types of problems that are like this that need to be addressed. So, okay, that's all. Thank you. Goodbye.